Hello everyone, welcome back to Ruijie RCNA class. I'm Nick Xia. Today I will teach you a dynamic routing protocol, OSPF. One day, Tom receives a new project. This time, custom require him to make all of this user's traffic to send to call switch 1 this export, and call switch 2 just for the backup. If you were Tom, how will you configure? Think about it. So, first we need to add all of this downlink to the relevant VLANs, and then the link between access and the aggregation switch, we should change them to trunk. Then, for the aggregation and the call switch, here is we should change this port to the routing port. So Tom's in last course, he learned the static route. So he said we can try to use static route and then use the static floating route. Use the switch 2. Then this one will become the backup. Yeah, this is a good idea, but could we simplify the configurations? Yeah, someone said that we can try to use default route. Yeah, it's better, but if there are 100 aggregation switches, I think you don't want to configure them one by one. Yeah, so today I will introduce you a dynamic protocol. Open shortest path first protocol. The AD is 110. It measures the path cost by interface bandwidth. So the more bandwidth, the smaller cost. And this protocol can also run on a large or medium-sized network. It has two versions, version 2 and version 3. So if you want to configure OSPF, the first step is enable the OSPF process. We can use command router OSPF then with a number. This number is the process ID. It's just local used, will not exchange to other device. Okay. Then we need to use the command network to enable which interface you want to use OSPF. Okay. So here, just pay attention. The command network means we enable the interface which belong to this network. Okay. Here we can see more information here. We have 3 interfaces. So 3 subnet. We use network, then 3 subnet. But if we use this command, think about what happened. If I network 192.168.0.0, we know this is a bigger network, and these 2 small networks belong to this bigger network. The answer is network command is used to enable interface. If we use this command, both these 2 networks will be enabled. It means these 2 interfaces will also run OSPF, just one command. Then I know you find that after the subnet, the values are very strange, because before it we learn IP address, we know after the subnet is the mask, and for the mask 1 first, 0 is later. Okay, then this time we find this number is called a wildcard mask. 0 first, then 1. And we remember the 1 values means this IP needed to be matched strictly. And for 1 values, it can be any values. So if we use this subnet, it means it will include this range 192.168.10. So after it, from 0 to 255, this wildcard mask is 1, so it's not required to match. It can be 0 to 255. Okay, just pay attention. It's different from the mask. It's called a wildcard mask. And we can configure SW1, 2, and 3. Then we can use the show IP route. Oh, we find that they already learn all of these networks routing conditions. Okay, SW1 learn all of these routes automatically. And we can find that 110, this is the OSPF AD value. The same to SW3 and SW2. And we have said the OSPF choose the interface bandwidth as the metric, and 100 megabit actually just equals 1 metric. So here, this link 100 megabit, the cost is 1, and then this link is also 1. So on switch 1, we can find that to this 10.1.4, to this network, the metric, the cost should be 1 plus 1 equals 2. Okay. And here is a summary of the OSPF routing principle. You can read them later. Just remember, for the two pairs, we should make all of the values same. And one other thing, for the OSPF, we need to know all of these devices, they don't exchange information between each other. OSPF has a better way. It will elect a designated router. Then all the other routers will send the information to the designated router. Then designated router will forward this information to them again. Okay, and for reliability, it will also elect a backup designated router. Just pay attention. OSPF neighbors do not transfer routing entries, but link state advertisements. This is OSPF packet, and it is used to describe routing information status. So each router advertises its interconnected device and directly connected network segments. The other device receive these LSAs. They will read it and then calculate their path. Then generate their routing protocol. After you configure OSPF, don't forget to use show IP OSPF neighbor. If the state is full, means they already finished the neighbor establishment. Okay, after learning OSPF Thompson, this is a really good protocol. But just one more problem. Because these links, they have the same bandwidth. So, in fact, at last, they will have the load balancing. But customer required call switch 1 for the export and call switch 2 just for backup. So Tom confused again. Yeah, I know. You remember we say OSPF use bandwidth to calculate the metric. So maybe you can change the bandwidth. Yeah, but OSPF provide a better solution. It can let you just change the metric rather than changing the bandwidth. So let us see how to change it. We can use IP OSPF cost. Then we change the value from 1 to 10. If we change this link, don't forget to change both ends. Then we can find that from here to SW2, we can find that the cost become 11. From 10 plus 1 equals 11. Okay. Now let us have a summary. Today we learned the OSPF and we know this is a dynamic routing protocol. We don't need to configure static route one by one again. So I think maybe you feel very excited. So I really recommend you to try configure it and then go back to answer our questions. Thank you for watching this video. See you next time.